Assalamualaikum and a very good day to Dr. Normah. We are from home going to present to you about biotin. Let's start with a brief introduction about biotin. Biotin is another example of water-soluble vitamin B that can be found in nature. It has many names such as vitamin H, vitamin B7 and vitamin B8. In the lower organisms, they can synthesize biotin in their system. Meanwhile, in some higher organisms, for example, us humans, cannot synthesize them by ourselves. Hence, we need to eat foods to obtain biotin for our bodies. Biotin can be obtained from egg, which the biotin is rich in the egg yolk. We also can get biotin from organ meat, such as livers and others. Biotin acts as a coenzyme for certain enzymes such as carboxylase, transcarboxylase, and decarboxylase, where all these enzymes are responsible for transporting carbon dioxide in other pathways. For the extraction of biotin, we do not find many research or methods regarding this. Some methods have been patented, for example, the methods for extracting biotin from the egg yolk. Therefore, we cannot obtain this method by ourselves. Thus, we only use this one that we found, which is the extraction of biotin from milk. There are few steps involved in this method. First is esterification of crude biotin concentrate. Biotin containing sample is concentrated and then was dissolved in methanol. It then undergoes filtration and the filtrate is concentrated into thick syrup. The residue then dissolved in methanol with dry hydrochloric gas. Water and solid sodium bicarbonate is added, turning it into alkali. Then it was extracted using ethyl acetate, then dried using sodium sulfate. Ethyl acetate is removed by filtration and the product is biotin methyl ester. Next is the decalso adsorption of biotin methyl ester. The biotin methyl ester is dissolved in chloroform and then passed through an adsorption column packed with meshed decalso in chloroform. The column is then washed with chloroform and 5% methanol in acetone. The eluate is then concentrated. Next is alumina adsorption of biotin methyl ester. Substance from previous steps are passed through column of activated alumina. The column is then washed with acetone, solution of 10% methanol in acetone, methanol, and solution of 20% concentrated ammonium hydroxide in methanol. It was then separated into few portions. Due to this, some eluate crystallized. Next is purification of the crystalline fractions. The crystal is washed with ethyl acetate until it becomes colorless. It was then further purified by sublimation at 150 to 160 degrees Celsius and some pressure. The sublimate is dissolved in hot methanol and peroxide-free ether is added. The biotin methyl ester was separated from the solution by using long thin needle. Finally, the step of obtaining the free biotin itself. The pure biotin methyl ester is dissolved in sodium hydroxide by warming. Then it was concentrated and made acidic by using dilute hydrochloric acid. Free biotin crystallized from the solution. To analyze biotin, we found three methods, which are using avidin binding assay, bioluminescence, and high-performance liquid chromatography, or HPLC. Let's talk about the avidin binding assay methods first. Avidin and biotin bind together with strong affinity. The binding of avidin and biotin can be measured by using spectrophotometric methods where there are two ways of doing it. Measuring the absorbance at 233 nanometer or measure the decrease in absorbance at 500 nanometer. For measuring the absorbance at 233 nanometer, it measures the absorption spectrum of tryptophan residue at avidin. When biotin bind to avidin, the max absorbance change from 280 nanometer to 233 nanometer. For measuring the decrease in absorbance at 500 nanometer, it used the concept of removal of p-hydroxyazobenzene 2-carboxylic acid or HABA from avidin HABA complex. Avidin HABA complex has maximum absorbance at 500 nanometer. When biotin is present, avidin have stronger affinity with biotin. Biotin will displace HABA from avidin and form avidin-biotin complex. The decrease in absorbance values at 500 nanometer show the presence of biotin.
Now, for the bioluminescent binding assay, a photoprotein aquarin was used. This photoprotein is originated from Aquaria victoria, also known as crystal jellyfish. The aquarin will emit the color blue and can provide an exceptionally sensitive to be detected at a very low levels, which around 10 to the power of negative 21 mole. The assays were designed on the computation between a known amount of biotin aquarin conjugate and a variable concentration of biotin sample for binding sites on the protein avidin. The binding of avidin to aquarin biotin conjugate causes inhibition of the bioluminescent signal emitted by the photoprotein. The graph shows that the inhibition rate drops down as the number of free biotin in the system increases. So, the higher the number of free biotin present in the sample, the lesser the biotin level photoprotein can bind with avidin, resulting in fewer amount of inhibition, thus leading to higher bioluminescent signal emitted by the aquarin photoprotein.
Next, let's proceed with another biotin analysis, which is high-performance liquid chromatography, also known as HPLC analysis. This method can be used to measure biotin in various samples, especially for pharmaceutical multivitamins preparations. For biotin detection, it was done without any previous or after derivatization by ultraviolet UV, either in pre or post column, in order to decrease assay detection limit. Assay detection limit refers to the lowest concentration that can be distinguished from baseline. Thus, HPLC can distinguish biotin with its main analogues, for instance, biotin sulfoxides, sulfon, and others. There are several HPLC methods developed for biotin. First one is reverse phase HPLC by using mu Bond-Dopak 18 carbon column. The detection of biotin is confirmed either in UV or fluorescent reagents. The detection limit, if we use this column, is 10 to the power of negative 8 gram per milliliter and 10 to the power of negative 9 gram per milliliter. In contrast, by using nucleosyl 18 carbon column, biotin will react with 9 and 3 entrial diazomethane, depicting 1 nanogram for detection limit. The other HPLC method used is anion exchange HPLC by using aquapore AX300 and particle SAS columns. HPLC managed to separate mixtures and sulfoside isomers in short period, and the detection limit is 10 to the power of negative 6 gram per milliliter. To summarize, from what is biotin to the extraction, followed by the analytical methods, including avidin binding assay, bioluminescence, and HPLC analysis, provide important information in a lot of different studies, for instance, biochemical, nutritional, and pharmacological. Many analytical methods have been proposed for measuring biotin, thus several improvements could be done in the future. I think that's all from our group. Thank you.